Right, okay, so now we're going to be doing question 8. Okay, ABCD is a parallelogram. Parallelogram. So what do we mean by parallelogram? It means that this is parallel to this, and this is parallel to this. So they're parallel to each other. We also know that this length is the same as this length. Okay, so we're also told that these two lengths are the same, which makes this thing the isosceles triangle. Now, if that's isosceles, then these two angles are the same, so this is 51. Okay, so which means that this angle here, ABP, must be 180 minus 2 lots of this 51, which is 180 minus 102, which is 78 degrees. So this makes this 78 degrees. And we know in the parallelogram that these opposite angles are the same. So that's also 78 degrees here. What else do we know? And by the way, I'm not 100% certain myself how to solve this question straight off. All I'm doing is applying information about what I know to the diagram, bit by bit. And eventually, I'm hoping that it will enable me to solve what x is, which is what I need to do. What else can I do on here? Well, I've got a straight line here. I've got an angle here, so this angle here must be 180 minus 51. So that is 129 degrees here. Okay, now what else do I need? What else do I know? Remember alternate angles, so I could start using that. So if this, in other words, let's just draw it on here temporarily. One second, what have we got here? I'll put you delete it afterwards, but I know some of you might remember these as Z angles, but you should really remember them as being alternate angles. This angle and this angle are the same. My red line went a bit skew with that. So this is x, right? Because of alternate angles. Notice in this question I'm not asked to explain. It doesn't say anywhere that I have to explain each step. So I'm okay just writing x like that. I could write it down if I wanted to. What about this whole angle here? This whole angle is 4x, the 3x plus the x. And we know that this angle is opposite to this angle here. That's also 4x. I don't know this one at the moment. Can I work that one out? Well, I can in terms of x. This little angle here is 180 minus the sum of these two. So this is 180 minus 129 plus x. Alright, now I can use these opposite angles here. They're equal. So I know that BAD, this angle here, which is 4x, is the same as DCB, which are both 4x. So therefore I can say that 4x must equal this angle here. Now what is this angle? Well, it's 51 plus this one, which I just worked out at the top there as being 180 minus 129 plus x, and this angle up here, which is x. So let's try and work that out. We've got a simple equation now with just x's and numbers, so I should be able to work this out. So we've got 4x equals 51 plus 180 is 231, and then I'm going to subtract them 129 and subtract the x, and then add this x. So minus x plus x, that's 0. So I've got 4x now is a 231 minus 129, which of course is 102. 2. So x is 102 over 4. Now what's 102 over 4? Divided by 4, 25.5 degrees. There we go. So bit by bit I've worked out what to do there. I do need to of course know that these angles are the same in a parallelogram. It's not always the case in any old quadrilateral, but in the case of a parallelogram it's true. Question 9. Rearrange v equals u plus at to make t the subject. Now remember how we did this in the lessons. We're starting off with t. What do I do to build this left hand side? So I start with t. First of all I'm multiplying by a, then I'm adding the u. So I'm going to do go reverse and opposite on each way. So we start with v equals u plus at. I'm going to subtract u from both sides. That's that done. And now I'm going to divide both sides by a. Okay, so there we go. So t is v minus u over a. Just reversing the equals. 9b. Complete this table with consistent metric units. So if we've got distance and time, what is speed? Well, speed is distance over time. And in this case, we've got distance is meters. Meters divided by time, seconds. So this is meters per second. Acceleration is change of distance, change of speed over time. So speed over time. The units of speed is meters per second, and the units of time is second. So let's look at this. We've got meters per second, that's this numerator, divided by, that's this divide by sign here, seconds. Now how do I divide fractions? Put this as a fraction, turn the second one upside down and multiply. So we get meters times 1 is meters, seconds times seconds is seconds squared. So if you didn't know acceleration is meters per second squared, that's one way of doing it. Of course you should know that acceleration is meters per second squared if the distance is in meters and the time is in seconds.